Covered arrays. Your learning target today is I can use the area model to decompose arrays into smaller problems. And you'll know you're successful when you can break down a covered array by finding smaller multiplication problems within the array. So as you know, we have been working with arrays with multiplication for a while now. And today, before I teach you about covered arrays, I'm just going to go over one more time an array like this one, where I could break it apart into the area model and figure it out little by little rather than just one big array, because this will be a strategy that we use today to help us with covered arrays, which is when I will not be able to see all of the dots in the array. But right now I have a full array that we have seen before, and I'm just going to use this, and you will be able to see how similar this is compared to a covered array. So I'm going to break this apart into the area model, and by doing that I'm going to look for a problem that I already know in the problem of this array. And I know that I have a 4 at the top, and I have, let's see how many dots, 1, 2, 3, 4, 5, 6 going down. And so if I split that 6, you see I split it in half already. I see a 3 and a 3 right here. So this top part would be the same as saying, instead of saying 4 times 6, this is like a 3 times 4 plus another 3 times 4, or 4 times 3, right? My 4 is staying the same in each problem because we still have 4 in each row, but our columns are different, or the number of rows, right? So we had split our 6 into a 3 and a 3, and there's our 3 and there's our 3. What would be 3 times 4? Well, I know that that's 12. And then I already did this step, right? Because this was a 3 times 4, and we know that is 12. So 12 plus 12 is 24, which means 4 times 6, or 6 times 4, is 24. And so let's look at the next problem with the covered array, and we're going to see what do we do when we do not see all of the dots. So here's my covered array. If I were to have this like on a card or a piece of paper, you might like see a flap of paper that would be covering what was missing. So I can draw that right there. But the point is that I cannot see what is under this. I can't see all the dots, which means I cannot count them one by one because I don't see them. But this is what we do when we come across this problem. It's really not much different than what we do with a regular array. So I'm going to see what's on the top, and let's see, how many dots do we have on top? 1, 2, 3. So this is a 3 by what array? Let's count how many we have going down. 1, 2, 3, 4, 5, 6, 7. So this is like a 7 by 3 array, which we know as the multiplication problem is 7 times 3, or 3 times 7. So how do I figure this part out? Well, if I already know my multiplication facts, I could already tell you the product, right? But how could I use this covered array to help me solve this problem? By using the area model, right? So we'll do the same thing that we did the last time with the area model, but we had the full array. I'm going to split one of my numbers. Why don't I split the big number? The 7 is big. And why don't I split it into a problem that I already know? So I know for sure right here when I have 1, 2, 3, I know 3 times 3. Here is our 3 times 3. So I know 3 times 3 is 9. And what do I have left over? Ooh, I also know this one, right? I know 4 times 3. So there is a 4 by 3 array, and here is a 3 by 3 array. So 3 times 3 plus 3 times 4 is going to be the same thing as 7 times 3. We just broke apart our covered array into smaller problems. And that's just like what we did with the array that I could see all the dots, right? We didn't count each dot one by one, so we didn't need them there. So we know 3 times 3 is 9, and I know from the last problem that we did, 3 times 4 is 12. So I have 9 plus 12 to figure out. And I know 9 is really close to a 10, so if I did 10 plus 12, I would get what? I would get 22, but I have to take away 1 because it's a 9, right? And that would be 21. So 21 is our product of 7 times 3, or 3 times 7. We know it's the same problem. So this will be our last problem for today. I want you to use what you know about arrays and about the area model, and I want you to figure out this problem. Okay, remember what we did to figure out what kind of array this is. Look at how many you have in each row, and look at your column, and that will help you to be able to figure out your multiplication problem. And then you can use splitting to break apart your problem. Whoops. So please go ahead and pause the video and try this problem on your own. All right, so by now you should have figured out the problem. And I hope that you are able to notice that this problem is 8 times 12 because it's an 8 by 12 array, right? So 8 times 12 or 12 times 8. And we are going to use this problem to break it apart and figure out what is missing out of our array. So by doing this, you might have done this differently, right? But you can split your array in many different ways. And so by thinking about times 8 facts, I'm going to split my 12. And remember, you could have also decided to use your 12 and have that be the same, and then just split your 8. It just would have looked differently. When I break apart numbers, it would have looked something like this rather than like that. Okay. Again, it could look different depending on how you did this. Okay, so I'm going to do 8s are going to stay the same. 12 is going to be split. And I know 8 times 4. That is a problem I'm really good at. And 8 times 4 is 32. I know that. And then I notice that I see another 8 times 4. And that's what I will do. So far my 12 is being split into a 4 and a 4 and probably something else. 8 times 4, again, 32. And I'm going to switch it up because I know 8 times 3 also. And I know that's 24. And then I only have 1 left, which means that is a 1 times 8. Which is 8. So I'm going to have to really make some room. And by doing that, maybe erase some of this so that I have enough room to do my work. So I have a 4 times 8, another 4 times 8, and a 3 times 8, and a 1 times 8. Okay. We know 4 times 8 was 32. We know that 3 times 8, I got 24. And then 1 times 8, of course, is 8. So 32 plus 32 plus 24 plus 8. So on the next screen, I will figure that out. All right. Again, we had 32 plus 32 plus 24 plus 8. And we know, let's break it apart. I'm just going to put these in parentheses because that's my hint that I'm going to solve that first. That's what I would call the order of operations. Whatever's in parentheses, I solve first. So 30 plus 30 is 60, and 2 plus 2 is 4. So 64 plus 24 plus 8 is what we have left over. Now let me figure out, let's do 24 plus 8 first. So we know 4 plus 8 is 12, plus here's a 20. So that's 32. So 64 plus 32 is our final problem. 4 plus 2 is 6. 60 plus 30 is what? 90. Oh my goodness. So you should have gotten 8 times 12 or 12 times 8 is 96. Nice work. So remember with covered arrays, it's just like a regular array, but not filled in with all the dots. So good luck today, and please do the feedback questions. So remember, your learning target today is I can use the area model to decompose arrays into smaller problems. And you'll know you're successful today when you can break down a covered array by finding smaller multiplication problems within the array.